Hi, my name is Michael Sullivan, author of Statistics: Informed Decisions Using Data. I want to thank you for your interest in the 6th edition of this text. Choosing a textbook is one of the most important decisions we can make as professors. It is important that we choose a text that contains clear, concise, and accurate explanations along with plenty of examples. The exercises need to build the students' confidence in the material, yet challenge them into thinking statistically. With over 2,300 exercises in the text, plus a wide range of resources available in the MyLab course, there is no shortage of material to help your students in their ability to create and consume statistics, as well as learn to think statistically. I would like to show you some of the hallmark features of the Sullivan Statistics series that have been built upon over the course of many editions. Hallmark features can be thought of as features that have been part of a textbook series for a number of editions. The hallmark features that I want to focus in on for the 6th edition are, first off, the side-by-side presentation of material. You see, the idea behind my philosophy in writing textbooks is to provide the instructor with the utmost in flexibility. To help you see what I mean by that in terms of the side-by-side presentations, go to page 377 to 378 in the textbook. So here we are on page 377 of the e-text, and if you scroll down to the bottom of the page, you'll notice that this particular example has to do with finding the area under a normal curve. Now, instructors have different philosophies as it pertains to the use of technology in the classroom, and so recognizing that is important from an author's point of view. So what you'll notice is that on the left-hand side of the solution, we provide a by-hand approach to finding area under a normal curve. That is, converting a normal random variable to a z-score, and then using the table, the standard normal table, to find the area under the curve. Whereas the approach on the right is to take a technology approach, where we use a variety of technologies in order to find areas under the normal curve. The main technologies that we use in this textbook are the TI calculator, Minitab, Excel, and StatCrunch. Now let's see how side-by-side presentations are utilized when talking about hypothesis testing. So we're going to go to page 498. Now with hypothesis testing, there are a variety of approaches that instructors can take. First and foremost, of course, there is the classical approach to hypothesis testing, and you'll see that in step 3, that's the approach that we're taking in the column on the left in this particular example. On the right, we're talking about the p-value approach, and even in the p-value approach, the philosophies differ. Some instructors prefer to use a by-hand approach, and so we are doing that right here, and other instructors will use a technology approach, and so we're doing that here, again utilizing Minitab. After we complete the 4th step where we make a decision rule, we come back to step 5 and the solutions merge back together again. And so again, we're providing the instructor with the utmost in flexibility in terms of the approach that he or she wants to take in teaching the course. Another feature that exists in the textbook is something called putting it together. We have 2 different types of putting it together. We have putting it together sections, and we have putting it together problems. As an instructor, when I'm teaching, say, hypothesis tests for a single population proportion, the students, when they're working in that section, of course, know to do the methods of hypothesis tests for a single proportion. However, when it comes time to take an exam, when the different types of problems are mixed up, the students struggle. Why? Because typically they haven't had practice in deciding what method to use in performing any kind of inference. And so that's why I have these putting it together sections. I have a putting it together section in 5.6 for probability, a putting it together section in 9.5 for confidence intervals, 10.6 for hypothesis testing, and 11.5 for comparing two population parameters. I'll come back to putting it together problems shortly, but what I want to do right now is show you section 11.5, putting it together. So section 11.5 is putting it together. Which method do I use? And the section begins with a flow chart so the student can follow the logic of any particular problem. That is, after you read the problem, figure out what parameter is addressed in the hypothesis, in the statement to be tested, and then follow the flow chart from there. Dependent or independent for a mean? Am I testing a hypothesis on a standard deviation? So on and so forth. That will help the student in deciding what approach to take in solving the problem. And then we have a mix of problems within the section. And now what I've done here is not only included problems where we're comparing two parameters, I've also included problems that involve a single parameter. So for example, look at problem number 13, where we're looking at the speed of a fastball. Here we're doing a hypothesis test on a single mean. And so students have to realize the type of language involved from previous chapters as well as the current chapter. In addition to mixing up the problems, if you go to the end of the section, you'll see that there are problems where all we do is give a scenario, and the student, based on the scenario, has to decide what parameters are being tested and what methodology would make the most sense. So for example, number 31, does drinking 2 cups of water before a meal assist with weight loss? What kind of hypothesis test and statistical inferential method would make sense in order to answer that research question? In addition, we have putting it together problems. These are problems that are throughout the textbook towards the end of a given section exercises, and they essentially allow the student to see how the whole statistical process plays a role within a given section. So for example, here we're in the application of the normal distribution, and we are doing things like drawing histograms, finding population means and standard deviations, fitting a normal model, and finding area under the curve. That way students can see how previous content applies to the content we're currently learning. Another thing that I've noticed is that if students aren't continually being reminded of skills that they've already learned, they tend to forget or lose those skills. And so to help address that, I've added what are called retain your knowledge problems. These are problems that have nothing to do necessarily with the material in the current section, but allow the student to practice skills that they've learned earlier in the course. So here, for example, we're in chapter 11 on inference of 2 population parameters, and yet this problem number 24 on graduation rates has to do with least squares regression. Again, that was back in chapter 4, so the student is retaining the knowledge of regression later in the course. That way, they're more likely to be prepared for the final exam. Another feature that we have in the textbook is a student activity workbook. There are many both tactile as well as applet-based activities that exist throughout the text. The student activity workbook is found in the MyLab course on the left navigation bar, and you can see a list of all the different activities that exist, along with links to applets that might be used within a given activity. This is a great way to engage your students in active learning, where they learn via discovery and hands-on approach as opposed to being lectured to. To assist students who are struggling with a particular problem in a MyLab exercise, we've added what is called MyLab Technology Help. The Technology Help is for the TI calculator, StatCrunch, and Excel. You'll find that the Technology Help under the learning aids within a given MyLab exercise. So let me go to the study plan, and I'm going to open up section 4.2. And what you'll notice here is that in section 4.2, some of the problems have -T behind them. That means that the learning aids assume that the student is using technology to solve the problem. Let's see what 29-T looks like. Under question help, you'll notice that there's a tech help button. This technology help was written by me. And again, we're going to provide students with technology help for the TI calculator. Here we are drawing a scatter diagram, finding least squares regression, StatCrunch, and Excel. So students can utilize this to remind themselves how to use the technology to get the output they need in order to answer this question. Now, one thing that I want to point out is that later in the course, when we're in the later inferential chapters, the technology help builds, because I don't want to just simply give the students the technology help for inference about two means, because we're giving away part of the solution or part of the skill that we want the student to develop, namely determining the correct inferential method. And so here, when we're testing hypotheses about two independent means, if the student clicks the technology help builds, meaning we provide all the technology help for all the inferential methods up to and including the section that we're working on. This way the student has to first identify the type of problem that, or the correct inferential method, and then select the correct link to bring up the technology help. So here we are testing hypothesis on two independent means for StatCrunch. There's the help for this. The growth in the number of students that are taking introductory statistics is incredible, and therefore there are many instructors that are being asked to teach stats for the very first time. We recognize that and want to provide those instructors as many resources as possible to assist them in becoming effective introductory statistics instructors. And so every single chapter in the textbook has an instructor's resource guide. The purpose of the instructor's resource guide is to highlight key things to emphasize within any given section, along with additional examples that can be used in the classroom. Lastly, I would encourage you to visit sullystats.com. On sullystats.com, we have a lot of statistical resources. If you click Stats Resources, you'll see ideas for your introductory statistics class. That includes websites and data sets, videos, and a chapter-by-chapter listing of ideas for teaching the different content. So if you want to have some ideas for how to teach sampling distributions, click Chapter 8, and we give you some ideas for how to approach this particular topic. In addition, some of the sections list out additional data sets that you could use within your classroom. And so the goal here, not only with sullystats.com, but with the textbook in general, is to provide you, the instructor, with as many resources as we can in order to provide you with an effective introductory statistics course.